Alright guys, so in this video I'm going to show you how to find nth roots of a complex number. So far we've actually explored the Dumas theorem, and I'm going to write the Dumas theorem on the board right now just to refer to it as we go through the next one. So Dumas theorem is a formula created by Dumas used to actually find complex numbers to a given power. And to use the Dumas theorem, we first need the Euler form. So the equation I've written on the board right now is called the Euler form. And the Euler form is actually quite interesting because it gives you the magnitude and the argument also in that form compared to the Cartesian form, which is just a plus bi, and it gives you how many units it has moved on the real axis and how many units it has moved on the imaginary axis. So that's how the Euler form is interesting. Then what Dumas came up with is that Dumas came up with the equation whereby you're taking a complex number and then you're taking it to a given power, so power n. So if you do that, then it's Rn cos n theta plus I sine n theta. So that is the Dumas theorem, whereby n can be a value usually greater than 1, because if it's power 1 it just stays the same as the previous equation. So n is 2, 3 and then upwards. Alright? But Dumas theorem actually is extended even further, so that we can use the Dumas theorem to find the nth roots of a complex number. And this is exactly what we're going to explore in this video. So we're going to use a formula derived from the Dumas theorem to actually find the nth root of a complex number. But what are we really talking about when we say nth root? So nth root means that you're trying to find z to the power of 1 over n. This is what nth root means. So what does that actually mean in terms of numbers? It means that you're trying to find z power half, or z power 1/3, or z power 1/4. So this is what you're actually trying to find. So z power half means you're trying to find the square root of a complex number. Z power 1/3 means that you're trying to find the cube root of a complex number. And in the same way, z power 1/4 means that you're trying to find the fourth root of a complex number. So if this is what you're really trying to find, then the formula is given by zk is equal to r to the power of 1 over n, open bracket, cos of theta plus 2k pi over n, close bracket, plus I sine, and then the same angle, which is theta plus 2k pi over n, and then that's the formula. And it's important to remember that the Dumas theorem is given to you on the information booklet. So this one is actually given to you, this line here. However, the nth root formula is not given. So it's going to be a formula which you'll have to remember for the exams. Now let's try to put it into practice. How do we use it? So let's say they ask you to find the root of 1 plus I. So when we're trying to find square root of a number, we know that there are two possible answers. If you're trying to find the cube root of a number, you have three possible answers. If you're trying to find the fourth root, you have four possible answers, okay? So that's something you need to know from previous knowledge. So if you have to find the square root of a complex number, so root of 1 plus I, we can use the formula, okay? And here zk represents the different roots. Okay, the different roots. And then there is something I didn't write here. There is the property of k described. So k starts as from 0 and then goes upwards. Okay, till n minus 1. So that's the whole formula now. But how do we use it? Okay. So to use the formula, you need r, which is the magnitude, and then you need theta, which is the argument. So first thing you need to do is you need to find theta and r. and it's something you've practiced quite a lot since the beginning of the chapter. So to find r, you do root of 1 square plus 1 square, so that's root of 2. Okay, and I'm actually working with the complex number 1 plus I right now. Okay, so that's what we get for r. And to find the argument, we can quickly do a sketch. So 1 unit on the real axis and 1 unit on the imaginary axis. It's here. So the argument will be this angle here. So theta will be tan inverse of 1 over 1, which is pi over 4. So we do have the r value, and then we do have the argument also. So now what we need to do is we just need to use it in the formula. So if I use the formula, the r will be root of 2 to the power of 1 over 2, because the n is actually 2 here, because the question is find the square root. Square root is power half, so the n is 2, okay? So you get root of 2 to the power half, cos, and then you replace, so the theta is pi over 4 plus 2k pi divided by 2 plus I sine the same angle. So pi over 4 plus 2k pi divided by 2. Bracket. Oops. Alright, so this is the application of the formula, okay, with the values of r and theta we found. And then from here you actually need to simplify. The root of 2 is 2 power half. 2 power half to the power of half is actually to the power 1/4. Then you simplify the inside. Actually, there's not much you can do with the inside, so I'm just going to write it in the same way. So you get that. This stays the same. 2k pi divided by 2. So we now have the expression which will give us the possible answers. So to get the first answer, we actually need to replace k by 0. So the first solution, ZO, will be 2 to the power 1/4, open bracket, cos pi over 4 plus 2 times 0 times pi, which will just be 0 divided by 2, and I sine, same thing, pi over 4 plus 0 divided by 2, and pi over 4 divided by 2 is pi over 8, so you end up getting 2 1/4 cos pi over 8 plus I sine pi over 8. So that's the first answer. But since it's a square root, we actually have two possible answers. So the second answer will be Z1. So we already replaced k by 0, now we're going to replace k by 1. So it's 2 power 1/4 cos, open bracket, it's going to be pi over 4 plus 2 times 1 times pi, so that's 2 pi. 2 pi over 2 plus I sine the same angle, so pi over 4 plus 2 pi over 2, which gets simplified to 2 1/4 cos of 9 over 8 pi plus I sine 9 over 8 pi. Alright, and this becomes the second answer. So if we had to deal with the cube root, then we would have a third answer. Then you would actually replace k by 2. And in the same way, if you had the fourth root, then you have one more answer. So you just need to remember that square root gives you two answers. That's why we have two answers here. Cube root will give you one more. So I'll just replace the k by 2 and work it out. But in essence, that's how you use the formula to calculate the nth root of complex numbers.